This is Rajiv Srivastava. I'm Principal Engineer with Wells Fargo. And let's kickstart this session with a thought note, how we can get generative AI performance without putting a hole in pocket using commodity edge devices like mobile we use it, a low cost CPU and IoT sensor devices. So I think you must be aware, like all the generative AI, I think I bet you all know about generative AI, what everyone is talking about that, it is very interesting topic and everyone is talking about it in IT industry. So I'm not sure how much you are aware about edge computing. So can you please raise your hand who is aware about edge computing? Okay. And have you used in production? Have you taken it production? Have you used any? Okay. IoT sensors? Anyone from IoT? Okay, good. So this entire session is, I'm not going to teach about what is generative AI and how it is implemented, how we can do all those model training, right? This talk is totally related to architecture, performance, how we can get optimized performance with better efficiency, with better security in lesser cost. So that is all about this topic. So here in this topic, this session we will cover about generative AI at scale, how we can train the model. Then we can also discuss about estimated growth to train large language model. Then generative AI training and operation challenges. Also we'll discuss how we can solve these challenges through generative AI, through cloud computing, because most of the like ChatGPT, OpenAI, but mostly are deployed on the cloud services, hosted on public cloud. So we will also discuss to how we can solve it through cloud computing and what are the cloud computing challenges, because there is a easy way to use cloud SaaS as service for all the machine learning, all the ChatGPT and all the services which is a large language model available. But those are very expensive. So we'll discuss more into what are the different challenges related to cost and latency and all those. And then we'll discuss a couple of use cases and also discuss about system design considerations, how we should design a system, efficient system which will cater better performance with a low cost. And finally, maybe in the last section, we will discuss a couple of running cost and optimization techniques. So first, I think first half we'll discuss about the performance challenges, and the last but not the least, we'll discuss about what are the different cost cutting concerns, what are the different optimization techniques, how we can reduce our large language model, and accordingly. And then in the last, we can ask 4 or 5 minutes. We'll discuss about questions. So this is very quick about me. Yeah, I have already introduction is already done. So I also this is my book, Cloud Native Microservices with Spring and Kubernetes. It is based on all cloud native microservices and how to kind of this Spring. It is available online. Also, I'm author and blogger of cloudificationnzone.com, where I publish, design, build, run, manage, and secure cloud native modern applications. Also, I cover a lot of architecture topics. And also I publish my blogs on public portals like DZone, Medium, Squadcast. Okay, so the very important thing, I think this is just a comparison for last 9 years, how generative AI is scale, how generative AI is growing from 2017 to 2024. So if you see on the first transformer, which is large language model, which had 65 parameters. The model size was 65 million. Then BERT came in 2018 and it had 340 million. Then GP2 came in 2019, which had 105 billion parameters. And Turing GPT-3 came in 2020 with 175 billion. You can see the rapid growth, massive growth is there, and every year I'll give the number. So this number I've got from very popular survey portals and journals. So migration, Megatron Turing came with 530 billion, Then GPT-4, which recently launched in March 2023, had 1.5 trillion parameters. And we're expecting GPT-5 is coming with 2 to 4 trillion by 2024. It is expected launch in 2024. We don't know exact the date, but maybe March by end of this year. So this is the important one. So here is estimated go to train large scale machine learning system. So here you see, right, these are the numbers, like the 2 million times estimated growth of computing cost to train machine learning systems since 2010. Then the 3 million estimated growth of computing power since 2012, and 60% estimated growth of environmental cost, which is CO2, since 2012. So when we train any model, it requires a lot of electricity, water, and many other resources to cool down the systems, to operate all the data center. It emits a lot of carbon dioxide, so it impacts our environment also. It's not eco-friendly approach. So that we will discuss what are the different impacts. So these are very high level numbers, which is actually giving how this generative AI training is going to scale from year to year on year, right? So it's all growth you can see. So next slide is giving a better picture. So here you can say this is a research report. So I'm just taking a simple example of ChatGPT-3, which is very popularly used by ChatGPT. And I think, how many of you are using ChatGPT? You are aware, right? ChatGPT is very intuitive and easy tool to give you all answers. If you can just ask any questions, like you want to itinerary for any country, it will give you all the day itinerary. It can also give you technical answers. So anything it's possible with that. It is trained with this data. So I'm just giving this ChatGPT example, which is internally using GPT-3 Gen AI LLM. So on the left side, you see like running cost estimation. So in running cost actually is taking 175 million parameters, 175 billion, and RAM is the running cost each day. It is actually serving across the world different requests. So we are maybe hitting from India, but many countries are hitting. So it's each day calculation. RAM is being used per day 350 GB of RAM, and VRAM 2048 GPUs. And $0.6 million US using NVIDIA A100 GPUs. So mostly GPUs being used internally. It is high power processing processors. Then this is the training cost. I mean, you can see that the number is so high. And just imagine it is computing cost is 4.6 million US, and there they use 28,500 Tesla V100 cloud instances. Then CO2, this is a figure on the right side, how much carbon dioxide emitted. So it was 502 tons plus water wastage, 7,000 liters of fresh water. So these are some of the some of the stats which I have taken from survey. On the right side, you see that emission. So here I am comparing basically how much CO2 has been emitted and impacted our environment, because we should also consider our environment whenever we do. I mean, as a developer, we don't consider much about how much we are polluting environment through our computing, through our coding and all. But internally, it is using hardware, and hardware is emitting a lot of gases and electricity. It needs a lot of water also to cool down. Air conditions are there. So multiple things impact carbon dioxide impact. So here is just a simple comparison, like when we do a simple air travel from one city to another city, it emits actually 0.99 CO2, okay, but if you compare with the GPT-3, its number is too high, 502 tons of CO2 emission. It is impacting entire Earth environment, and it is not actually friendly. So that's why these are some of the basic major challenges we are trying to solve it, how we can distribute our workload or train in a different way, so that we can save our earth and also save cost without compromising performance. This is all about the topic. So for example, I'm just quoting example to cut costs. Companies to tend house their own LLMs with expenses varying widely based on model size, And they are also using even a small large model and very small large model also, which can be trained on edge devices or mobile. So, okay, anyone can give any example of edge computing? I mean, very popular example of edge computing. What, sorry? Yeah. Anything else? Any other device, hardware device? So mobile, like, that's a very important and very known example, popular. So we use a mobile for everything. So it is also part of edge computing. Even your browser using in computer browser, your laptop is also edge computing device. So we'll discuss more into that and we'll connect how we can solve these challenges using that. So let's move to the next topic. So these are some of the operation and training challenges. So there are two things, like whenever you need any large language model, you have to do two important things. You have to train that model, and then you have to run that model. So run means operations. Operation means you need to deploy it, and you need to do all the maintenance part, backup, and all those operational activities, CI/CD kind of. So in generative AI trainings, there are five major challenges we have. First of all, like rapid growth in model sizes. So you saw that the last slide where I have shown all the scaling from last 9 years. It is growing up and up. So where you can see the model size is doubling every 6 months, like generative. Okay, maybe I have to mention that diagram first. Yeah. So 15,000 times increases in 5 years. This is the growth, and every year it is increasing 10 times that parameter size. So this is one of the challenge, right? To every year it is increasing 10 times, so we have to find out some solution. Solution will come up. Then there's another challenge of training and operation challenges of this is high power consumption. It needs a lot of electricity because you need to deploy GPUs and many other hardwares, servers, storage servers. You need to store the data on different storage devices or either cloud or on-prem. And also you need software to operate it. Then next one is third one is slow performance. So it is not built. In some use cases you cannot rely on generative AI use cases. You cannot ask ChatGPT for any kind of critical operation where you need real-time processing. For example, security systems or healthcare monitoring. In ICU, you see a lot of machines are there, right? So those machines are also using internal logic. They don't connect to the cloud or get all the data from somewhere else. So all processing, most of processing happens locally. Then there is also an issue of unreliable infrastructure. So transmit high volume data. So whenever we train any large language model, we get data from different sources, could be mobile, sensors, or different computing devices. So the computing cost and transmitting cost is very high. So we need to also cater it. So for one of the best example, I can see YouTube videos or Netflix videos you watch. So whenever you see watch any video, it gives recommendations. But internally it does it is all based on generative AI machine learning algorithms. So internally it does all the curation of the videos, and it takes off a lot of time to go through all the videos and identifying content, and then make a relation between the. So let's say if you are very particular to one of the song, one of the movie, and you are watching that, so similar kind of movies it will display in the background. So automatically it will show on you the next playlist. That all happens through that. But these, if you include anything media content, either images or video, the processing time gets faster. Processing time will be lesser because here it needs a lot of curations and analysis of the videos and making relationship with the videos. And also a lot of transmission is there. So the last one is increased output dimension. So it needs high computational and storage hardware costs, because you need to train the large systems which needs thousands of GPUs. And one of the more important reason also, like these all hardwares are mostly built in Taiwan. and Taiwan is dominated by China. So because of these geopolitical issues also, demand is too high, supply is lesser. So we should also come up with some solution where we can train our model without high-end systems like GPU or TPUs. Set up costly infra services need a large number of GPUs, right? So this is not a good idea to do all the trainings on cloud systems. So okay, so what is the answer to solve these problems, solve the challenges? Do you think cloud can solve all these challenges? Because cloud also has some limitations, right? It has a lot of limitations. So let's discuss very quickly. So it has high data transfer cost. Whenever you go with any public services, they use internally GPUs, TPUs, and LPUs. Those are very expensive. Then it also has a low latency. It has high network cost and a long distance servers. So sometimes servers are distributed to different regions and countries, which makes it slow performance. It is not good for real time processing, where we need the critical data in milliseconds or maybe microseconds. Privacy concerns also there, like many companies, mainly financial companies, they don't want to share their data to centralized servers. There is also network connectivity issue. Let's say you are getting data, you're training your large language model from different sensors, IoT and mobile devices, and they are not into good network, you'll not receive the data properly. Then there is a limited processing power issue also, where real-time application demand more power than the cloud can provide, right? So cloud is scalable, but due to cost we have some restrictions. We cannot use entire cloud. Companies also have some restriction to control the cost. And also it is a non-eco-friendly because internally it is deployed on large data centers which emits a lot of carbon dioxide. So what is the answer? So let's introduce a game changer, AGI computing, which is a new concept. AGI has been popular for last 4 or 5 years now, and there many people are actually experimenting. So it is currently very popular with the cloud computing, because cloud computing also we can do with the edge computing. If you need if customer need very high speed performance, quick performance, then some application deployed very close to the customers. So same concepts can be used with the training with the LLM model. So we can deploy edge devices. So what are this diagram, this slide will discuss about what are the different, what are the benefits, right? Why Gen AI at the edge? And I will cover only the top 3 one. These are others are also the benefit, but in interest of time, we will cover only the top 3, which are relevant to this topic. So first of all, it reduces the cost, because it internally when you deploy anything, right, you train your large language model or small language model or very small language model, it takes a very less memory footprint and processing speed. So the cost will be lesser, the data transmission cost will be very lesser, because you can split data into 2 parts. First part should be on edge and another part would be on the cloud. Then second is a faster response time. So whenever if anything is closer to customer device, it will be very fast response. It won't call cloud services. It will call the edge devices, services, and get the data quickly. Then third one is a low environment impact, because if you train data in a chunks or using metadata trainings only, right? So then you don't have to push a lot of effort, and then energy consumption, electricity, everything will be lesser. So that will cost very less. So that the low environment, so environment impact will be less. Carbon dioxide, CO2 emissions will be very less. So it's an eco-friendly approach. So now discuss how generative AI system design can be done on edge. So if you see there are 3 layers: cloud, edge servers, and user devices. The top layer is cloud. So lot of systems are, so there are 2 kinds of large language model. One we can use generalized, and one we need to specific data, right, where you have very specific use case for your enterprise. There you want to just train your data only for a specific business use case, for example any financial use case or e-commerce related use cases. So you can split our data into 3 categories. So whenever you let's start from the bottom. where this person human is just entering some prompt, just like we do on chat GPT, and there we are doing with the user devices. So you just you enter any prompt that you want some information. So this will go to mobile application or web applications on that the second diagram, maybe this one. Then user data will be pushed to this one, this component. So this is divided into two parts. So this will send the sensitive data to edge servers and shared data, which is public data, to powerful computations on cloud. So user data, sensitive data is basically personal data, date of birth, all the social security numbers, or anything related to financial, right? So those are all very personal data which you cannot share. So we can split the data. So data transfer cost will be lesser in this too, and fine tuning, all the training will be happen on the edge servers. So this is pre-trained lightweight model which will give inference and return response to applications. And then edge server is there, which is on the left side is the green AI models, which is also being used for to train specific use cases, right? And then on the top you can see there's a large scale data set which is being used to train pre-trained model, and from this model the data will synchronize to edge servers. So synchronization happens based on demand, based on use cases. So it will this edge server model is not a replica of the main one. It has only information which is needed to solve the questions. So it's keep on synchronizing it. So these are some of the use cases where I will only cover the top one. So Google Photo ADs, I think there is a new feature come in Generative AI in Google Photos where you can just take a photo and ask to remove the background. So the background removal, you can change it, you can remove the background, happens at your local device. It is not going, it will not call to your backend services. So this is one of the example, and Google is already using it, edge devices, edge computing on your local machine. So through even plugin, it is doing all that curations and doing filtering logic is happening there. It is capable to remove your background. The second case is retail smart shelf. So Walmart and many companies are already using it in inventory automation. So it automatically detects whether product is available in the racks or not. If it is not there, it automatically orders through IoT sensors. So this is all happening through generative AI model. And some of the other use cases are being used can be applied edge computing with the generative AI, like healthcare monitoring, autonomous car, which is a driverless car like Tesla cars, real-time IoT devices, transportation and traffic, industrial automation, smart security system. So now let's discuss about running cost and generative AI training and running cost. So these are two major cost categories we have. First one is the training cost, where we invest more into data acquisition, right? So data acquisition means like obtaining high quality relevant data to train your generative AI model, where we either you can build your own data or buy data sets or buy licenses. So those are different ways to collect the data, right? That is one of the cost factor. And computing power, you need to buy GPUs, hardwares, storage devices to operate and store your data. Sorry. Then human expertise also need. So you have to train your in-house training team to learn generative AI and then apply it. So you need data engineer, machine learning engineers, data scientists, and all the DevOps team who manages your environment. Then second cost considerations are running costs. So one is a training cost, which is a one-time cost and very high, and continuously we need to train it. And another one is a running cost, where we need a hardware to run applications gradually, right? So the running cost is needed every day, like hardware cost is there, software licenses, and energy consumption. Energy consumption is all electricity bills and all. So this is a very important slide to discuss what are the different optimization techniques to save costs when we are training our large language model, or very large, or very small, and small language model. So there are some of the costs, if you consider it, whenever you go back and work in your organization and apply these techniques, you can save a lot of costs and you can bring value to your company. That these are some of the techniques we can use it, because many many companies are not adopting generative AI LLM because of cost reason. And when you go with the OpenAI or ChatGPT, the license cost is very high. So that is the problem. So let's start with the right side here. Commodity hardware. So we should use commodity hardware, so low cost laptops or computers to train model and operate it. So you can have multiple computers running LLM. So you can train your large language model from multiple computers. You can distribute it using distributed computing, and you can just utilize it as a single computer, right? So internally it connects and share data with each other, and whenever needed to the client, it serves the purpose. Then leverage on-device training. So this is the best way to train your language LLM on device, on edge devices, on your mobile IoT or any other IoT, on any other edge device like low-cost computers. So training should be done. So there are two kinds of training. One training you can do on the cloud side, which is a very generic one, but very specific use case if you have. Like even cloud is not necessary. If you have very small use case, you don't need cloud. You can use on-prem system, and there you can train your data and deploy. So your internal organization can use it in. The next one is efficient model training techniques. So there are different efficient model techniques available, like distillation is there, pruning, quantizations. So these techniques actually compress the your parameter size and reduce your large language model size. And when it reduces, means it reduces cost, it reduces operational cost, hardware cost, everything, and CO2 emission, all the three major categories which we discussed earlier. So distillation, pruning, these are techniques. So distillation, so quantization, like basically you decrease the size of parameters, you reduce the size. Pruning is like you, some of the data are not useful, so after training you just remove it, some of the redundant data. And distillation, where you reduce the size using, there is a technique I can give you better, 5 minutes, okay. So maybe I'll move to the next one. So then best practices, these are some of the best practices, like we should keep raw data at edge, so that we reduce data transfer cost by sending only meaningful data to cloud, understand business usage pattern, so based on what is your use case, frequently usage times, either frequently used or commonly used. You can use a Kubernetes container for auto scaling, use the power of 5G. So if you're training your LLM on mobile devices, so there you can use a 5G network, which is very fast, right? Faster than your normal database, normal your internet connectivity. And then you can use a limit token size with 4K, 16K, 32K. Yeah, that's it. I think I've covered most of the content. Maybe, so I'm just going through that quickly here. The left one. So the next one is leverage pre-trained models, use open source frameworks, reduce data transfer cost, efficient model design. So there are different ways to that. You can use batch processing to design model. You can use federated training, where multiple computers can train a model which can be deployed on-prem or on cloud. Then leverage on device local interference, and use also optimized model uses. So that's it all. Yeah, it took little more time than expected, but yeah, we have few minutes to discuss any questions. This is my LinkedIn URL, so you can connect with me and ask questions if you have. Maybe you can chat on LinkedIn. And this is my social profile. Thank you. Thanks.